Okay, so today, people, we are starting. Basically, we finished with derivatives, so now we're gonna work backwards. Okay, it's called integration or antiderivatives. Okay, so today we have introduction to what we call indefinite integrals. Indefinite means that they're not defined. Good. So definite integrals, we're going to talk about those later, but indefinite means that they are not defined. So it says here in the past two chapters, and more than that, right? We've been given a function f of s and asking what the derivative of this function was. Starting with the section now, we're going to turn things around. We want to ask what the function we differentiated to get the original. So basically, now I'm telling you, here is your derivative. Tell me what the original was. Okay? So this one's basically, guys, just the opposite of the power rule. Now, they get more complex. If I have something that looks like it was, I would use a product rule on it or a quotient rule, right? So right now, we're starting very basic. That's why I gave you the very basic warm-up, right? Just a regular old power rule. So guys, let me ask you this. With a regular derivative, what's the rule? What does the power rule tell you to do? So take your exponent, whatever it is, multiply it to the front, subtract 1. So then what do you think you're going to do here? Instead of subtracting 1, you're actually going to add 1. And then it's kind of weird because what you're going to do is what I like to call, like, you got to counter it. You have to counter it. So you know that that exponent should be up front, but if it's not, then you have to count. There was something there that made it go away. Or if something was different than what it should be, you have to kind of make it happen, okay? So let me show you. So it says, what function did we differentiate to get the following function? So this was our answer at the end. This was our answer after we took the derivative. Got it? So I want to know what was the original. Well, very simple, okay? So if this was f prime of x, the original was what? Well, this is simple. So if I ended up with x to the fourth, what exponent did it used to be? So obviously that one's simple, right? However, think about it this way. If I were to take the derivative of this, what would happen to this 5? It would be in the front, but notice it's not there. So how would I make the 5 go away? I would have to divide by 5 or multiply by 1/5. Does everybody see how that works? So I countered in that front part because it's not there. So I knew that this 5 would come to the front, but since it wasn't there, there had to have been a 1/5 there that would make it go away. Does that make sense, people? Okay? Now let's continue to go. Now notice I have an x with no exponent, which actually does. It has an exponent of what? 1. So then it used to be an x what? Squared. Now think, if I took the derivative of this, there should be a 2 there. Good, but it's not. There's a 3. So then what was there? A 3 over 2. How do I know that? Because if I took this, when I take the derivative, 2 times 3 over 2, the 2's would cancel. I'd end up with a 3. You good with that? Okay? And then look, it says I just have a minus 9. How would I end up with just a constant after I took the derivative? There was an x there, correct? Agree with that? And then last but not least, because these are indefinite integrals, because there was indefinite integrals, notice there's nothing else, right? When I take a derivative and there's nothing, what was there? A constant, right? A constant. Now, I don't know what that constant is. It could be anything. It could be a million. It could be 1. It could be 2. It could be a fraction. But any constant would technically go away, correct? So with indefinite integrals, what we have to do, you have to do this. If you do not do this, you are wrong. You always have to say, look, here is your derivative, here is your antiderivative, but then it's going to be plus c. C, of course, stands for some constant. I don't know what it is, but I know that there's a constant there. Does everybody understand that? Okay? So when we're doing indefinite integrals, guys, I always, at the end, want to see a plus c. Eventually, that'll go away when we do something called definite integrals, when I actually define what my integral is. But in this case, since I don't know it, I have to add a plus c. Does everybody got that? How do I know I'm right? Take the derivative. Okay, if I were to take the derivative of this, 1/5 x to the fifth, 5 times 1/5 becomes 1x to the fourth. 3/2 x squared, 2 times 3/2 becomes 3x. And then minus 9x, take the derivative, just ends up with a simple, right? Got it? That's literally what we're going to do. Okay? Let's get some definitions in here. Okay? Basically, everything I just told you, just in an actual formal definition way. So I'll give you some time to copy that, or what you feel like is important. Alright, so here we go. Basically, it's just exactly what I told you. Antiderivatives, basically that's what we call, or integral, right? They'll say the same thing. If I say find the antiderivative, of course I mean integrate. If I say integration or do the integral, I mean obviously integrate. This is the symbol for integration. When you see this, this means to take the antiderivative. Got it? It's basically like an elongated S. And then of course it says here, so look, this is what you'll see. You'll see an integral symbol, an integrand, f of x dx. Okay, so it's whatever your function is, and then of course, what do you think this stands for? Yes, with respect to x. So basically here, it's telling you, what I like to tell my students is, always pay attention to these guys. These act as parentheses. I forgot an N, right? Parentheses. Okay. So anything in between these two things has to be integrated. So what does that mean eventually? There's going to be stuff on the outside, right? Do I have to integrate that? No. Got it? So pay very close attention to those things, all right? And then, of course, we talked about this earlier. I have to add that C. That stands for my constant of integration, meaning that there was a number there, but when I integrated, or when I took the derivative, it went away. I just don't really know what that number was, okay? Any questions so far? All right. Let's start with some baby steps here. Well, we kind of already did. So here I have this symbol, 6x to the fifth minus 18x squared plus 7 dx. So what does that mean I want you to do? Find the integral of this stuff here with respect to x, okay? All right, ready? For the first one? To the 6th power. Anything in the front that I need to counter? No. Why? Because that 6 actually showed up there. So there was nothing there, so it's just x to the 6th power. Good with that? All right, next part. Okay, good. So it's x to the 3rd, but 3 times what gave me the 18? 6. Simple stuff, right? Okay. Plus 7x. Good. Don't forget that. Plus c. This stuff's too easy, right? We good? All right. Notice the difference on the next one. So, remember I told you that the integral and the dx act as what? Parentheses. So do you realize that the only thing I am asking you to integrate here is what? The 6x to the 5th. So what do you think is going to happen to this stuff? It's just going to stay the same. So you're going to end up with what? Oh, I'm sorry, that's a 2. Well, do I have to put a plus c in this case? Because why? I have a constant. Okay? I have a constant. Any questions? You sure? Okay? Alright, I do have some rules. Okay? Let's paraphrase, alright? Let's paraphrase. We're not going to sit here and you have to copy this all day. So, the first one says this. The integral of k f of x dx is equal to k integral of f of x dx, where k is any number so that we can factor multiplicative constants out of indefinite integrals. Meaning this. If you notice that your integral or your function is, let's say, multiplied or can be factored by something, guess what you can do? You can factor it out and not have to worry about integrating it. Okay? So basically to make it smaller. Like for instance this. if I asked you, hey, what's the integral of 25x to the third power plus 10x squared minus 5x, okay? And what do you notice about all those? They're multiples of what? So I can make this easier on myself and take out a 5, and I'm going to put it in front of my integral. Why would I want to put it in front? So I wouldn't have to integrate it, because remember, that acts as like a parentheses, right? So if I take out a 5 from everything, then I'm left with 5x cubed plus 2x squared minus x dx. Okay? That dx, guys, it's very important. We're going to have to use that eventually, so make sure you write it on all the time. Okay? So that's basically what the first rule is saying. If there's a something that's factorable, take it out. Now what I want to warn you is this. Notice it's a number. So like most of you, some of you might have noticed, well, aren't they all factorable by 5x? Right? Because technically they all have a 5x in them. I do not want to take out a variable. Okay? I'm only at this point taking out numbers. Everybody understand that? The next one is basically a derivative, no pun intended, of the first one. It says here the integral of negative f of x, and then what can I do with that negative? Take it out. But isn't that the same thing here? Except negative 1, right? I can take out a negative 1 from everything. So basically the same kind of rule. If you can take out a negative from everything, do so. And then this third one is something that we pretty much already understand, what we've been using, that if anything's being added or subtracted, I can essentially just do it piece by piece. Okay? So like if I had a function like I've been having, where things are being added and subtracted, I can essentially just integrate piece by piece. Okay? So like what I was doing, technically, like for this one, what I was technically doing was this. The integral of 6x to the 5th minus the integral of 18x squared plus the integral of 7 plus 7. The integral of 7. You see what I mean? So I was just integrating piece by piece. That's all the third rule says. All right? And those are pretty much standard rules, right? They kind of make sense anyways, so there's no need to copy verbatim. Does everybody understand those rules? We good? All right. Here we go. I have 40x cubed, integral of 40x cubed plus 12x squared minus 9x plus 14 dx. Okay? So, bless you. The integral of 40x cubed plus 12x squared minus 9x plus 14 with respect to x. Plus what? Minus. So it would be x to the second power. So it would have to be what? 9/2 plus. Good. I mean, you guys, this is easy, right? Okay. And then obviously the difference between the first one and second one is what? Good. 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 So then essentially notice that this is my parentheses. So integrate everything in between those two things, and it's going to be the exact same. So it'd be 10x to the 4th plus 4x cubed minus 9/2 x squared, and then plus the 14 just drops because it's not within my window of integration there. So then, just like what Bridge said, I do not have to add, in this case, a plus c because this is my constant. Does everybody understand that? Okay? We good? Alright. I think this is my last one. Yeah. So, I have it. Why don't you try this one on your own? Try this one on your own. The integral of 12 t to the 7th minus t squared minus t plus 3 dt. Okay, this integral, it's in terms of t. Does that matter? No, especially because it tells me dt, right? It tells me do it in terms of t. Okay, do you think I'll ever have a time where it's like these are t's and then it tells me dx? Yes, that's gonna happen. Not today, but that will happen. So think about that though. What is that? It's kind of like implicit, right? Remember how we had a y and I had to derive my y in terms of dx, right? So it was just kind of like same rule, but then I had to add that dy dx. So something like that will be coming, okay? So it does happen. You are, of course, going to have multi-variables. So this one should have been pretty simple. What did you guys end up with? So it became 3 over 2. Everybody understand why it's 3 over 2? Right? Because it was, what, 12 over 8? Right? So, yeah, it's 12 over 8, but then, of course, I can simplify that to 3 halves. Right? So I don't... This is what this came from. And then the next one? Cubed. T squared plus 3t plus c. Don't forget that plus c. It's very, very important. Does everybody understand this? You sure? Okay, and then the last one, it's basically asking this. I gave you these things, so I want you to see how they'll ask it sometimes. Sometimes it'll be that simple. I'm just going to put that symbol, no questions, literally just that symbol, so you have to understand what that means. Of course, it means take the antiderivative. Or they can just say something like this. Determine f of x given that f prime. So then they're saying, here's the derivative, tell me the original. So then what are they trying to say? Integrate. Okay, so this is the long-winded way of saying integrate. Okay? So then if I ask you to integrate this one, how? What would you end up with? What would it be? You said, I heard you, 6 over 9, but of course that would reduce to what? 2/3 x to the 9th power minus 4x to the 5th plus 1/3 x cubed plus 9x plus c. Does everybody understand integration using the power rule? You sure? Okay. Sorry. Ready? Think you can handle it? It's not that bad, right?